Now that we have discussed constraint propagation technique, David, why do you think you did not see this as a 3D object?
So I think there's two reasons, actually. The first reason is that there's a junction right here that I just don't have in my dictionary of junctions. It involves 4 lines coming together at a point, but I can't deal with anything more than 3 at a y constraint. So the fact that I don't see this as a junction makes me not naturally see that as any kind of realistic shape. The other is that if I label these 3 intersections with their junctions, I'll get an L, a Y, and an L. If I propagate the constraint from the L junction, I see this is a blade, and this is a blade. If I propagate it from the Y junction, I see these are all 3 folds. But now I have the Y junction telling me that this is a fold, and the L junction telling me that this is a blade. So I have a conflict in my attempt to propagate my constraints down onto this shape. And the result, I guess, is that I don't see it as a shape, because it doesn't fit my constraints.
Now, of course, some of us do see this as a 3D shape. You can think of this as a paper folded here, one plane of the paper and another plane of the paper. This looks kind of like an open book. This particular line here then can be ignored, it just being a line on the 2 planes, not signifying a surface by itself. If we view this only as a line and not signifying a surface, then that addresses David's first problem. But how do we address David's second problem of this being a fold or a blade depending upon where we start the constraint propagation from? The answer is that we actually have a much more complex ontology of these connections. The answer lies in the fact that we have so far used a very simple ontology just to demonstrate the constraint propagation process. In reality, the ontology of these constraints is more complicated. Thus, the Y constraint may not just have fold, fold, and fold, but it might also be blade, blade, and blade. And the L constraint is not always blade, and fold, and fold, but it could also be blade, and fold, and fold, and blade. Now we can see David's second problem disappearing because the Y junction may have a blade and the L junction may also suggest a blade, and there is then no conflict. Let me note that what we have shown here is still not a full ontology of the Y, W, L, and T constraints. T constraints in particular may have additional complexity. The advantage of having a more complete ontology is that we can use that ontology to interpret more complex scenes, like this one, where there are 2 rectangular objects, one being partially occluded by the other one. Of course, the more complicated ontology is not without its own problems. It now introduces ambiguities of a different kind. This particular junction, is it now a blade, 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 or is it a fold, fold, fold? Both of them are permissible in the new complete ontology. In order to resolve some of these ambiguities, we can come up with additional conventions. One convention is that all of these edges that are next to the background, we'll consider them to be blades. So we'll make this a blade, 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 blade. Once you make all of these blades, then it's easy to propagate the constraints. Thus, this W junction could have been a fold, blade, fold, or a blade, fold, blade. But if we adopt the convention of labeling all of these lines as blades, then this W junction can only be blade, fold, blade. But if this is a fold, this Y junction can only be fold, 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 and so on, and that helps us resolve the ambiguity of what this junction could be. This task of image interpretation is an instance of the abduction task. In abduction, we try to come up with the best explanation for the data. This is the data, we're trying to interpret it in terms of an explanation. We'll discuss abduction in more detail when we come to diagnosis. For now, notice that we start with what we know, blade, 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 and then we propagate the constraints so that we can disambiguate between other junctions.